Alright, so I'm filming now. Alright, so lower side looking up. So I'm just going to go here, and you're just going to go look off to the side. Nice. Okay. Now I'm going to get on, yeah, I told you, it's really easy. It looks silly, but it's going to go together well. Welcome to Northeast High School Science Department. Today, our super scientist team is going to take on a special challenge.
Found in a dusty box deep in the chemical storage closet were these unmarked elements and compounds.
We will conduct experiments on each of these items and gather data about their physical properties. Then, we will add those physical properties to this data table, and once we get enough answers, we can identify the unknown element. Then we will use this power to discover the secrets of these mysterious items.
Excuse me.
Our first experiment is going to be performed by one heavy hitter. You may have seen her in Google Meets. You may have seen her in your community. You may have seen her dance. But when she's in this lab, she is Hammer Girl! Hammer Girl, could you tell our listeners what kind of experiment you're going to perform?
Okay. Today I'm going to test out all of these different items to see if they are malleable and test for brittleness. Wow!
Excellent. Could you tell the listeners what malleability means?
When an object has high malleability, it's easy to bend, like this wire. But if the object has low malleability, it's easy to break and bend under pressure, like this piece of chalk.
Ah, great demo, Hammer Girl. But how are you going to test the malleability?
We're going to take each item. We're going to make sure that we have on our safety goggles. Always safe. And then we're going to take and hit them with big hammers.
I'm going to go stand over here. Hammer Girl, you may proceed with the experiment.
Yes. Girl! Wow! Nani?
Wait, Hammer Girl. You're going to ruin the consistency of your experiment. It's not about if you can break the items. It's about if they break under stress. We need to collect our data.
Item number 1 is brittle. Item number 2 has malleability. Item number 3, very brittle. 4, super brittle. And 5, malleable.
Let's add these results to our data table.
Yes. This is most interesting. We did get some data, but not enough to determine what these elements are. We need more. So on we proceed to our next experiment. Our next experiment will be performed by one fiery teacher. This test will be dangerous, but danger is her second cousin's middle name. I give you Ultra Inferno! Ultra, I gave you that awesome intro, and you don't even have a lab set up.
I haven't set up my lab.
All right, proceed with your experiment, Ultra.
Okay, man. Element unknown number 1 to the Bunsen burner. Element number 2. Element number 3. And number 4. What we will measure is the time it takes for each element to melt. The less time it takes to melt, the lower the melting temperature is for that item. It's like we have results to add to our data table.
The results are in, and it appears that all the elements are resistant to Ultra Inferno, except for one.
Wow, that is a great experiment. It really shows us the strength of the bonds between the elements in these unknown items. We still don't have enough information, though, to identify these unknown items. We have yet another test that we need to do, but I'm afraid that we don't have time for you to clean up your lab.
Domo or doctor information. I must go now.
Nani? That was a great experiment. Knowing the bond strength between elements really could give us some insight about their physical properties. I feel like, though, we don't have enough information. We must conduct another test. Our science team is amazing, isn't it? We have yet one test left to perform, and this requires the use of deadly electricity. I only trust one person to perform this test. You know her on the streets as Miss Greenwood. You may have seen her jogging through your community. But in this room, she is Static Charge! Welcome, Static Charge. What test are you going to be doing today?
I am going to be testing the conductivity of each unknown sample.
Conductivity. The ability to transmit electrons. How does this test help us find out information about the physical properties of our unknown elements?
Metals are good conductors of electricity and heat. Non-metals are poor conductors. You use non-metals to insulate electrical wiring.
This data will be most helpful. Static, how do you measure conductivity?
I use my multimeter to put a small charge into each sample. If the sample is conductive, it will beep.
Okay. I'm excited for your results. Please begin when you are ready.
Let's add the results of Static Charge's experiment on the items to our data table.
It looks as if we have enough information to begin classifying our elements. Nani? No explosives or radioactive material? Just everyday mundane items? Ah! 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 Domo arigato for joining us at Northeast Science Department Laboratory. Stay tuned when next week we look into testing mind control devices.
Your sharp eyes may have noticed that some of our results did not match up to the classifications that they were given at the end of the experiment. There's an answer for this, and it's simply that if you look at the periodic table and see where these two particular elements are located, zinc and carbon, aka graphite, you'll notice that they are very close to a group of elements called metalloids. And metalloids are elements that have physical properties of both metals and nonmetals. So in this case, what we would have needed to do was additional tests on other physical properties to see more information and get a more accurate classification of these items. And here's a list of other tests that you could do to test for physical properties.